Okay, let's really quickly talk about finding the derivative and then finding the tangent line to that derivative at that point. So remember we said derivative just means slope of a tangent line. And then, so this one says find the derivative with respect to t of this function. And then it says to find an equation of the tangent line to the graph at 1, 2. So basically what they're saying is please find first the derivative of the function being y equals 2 over t at the point 1, 2. So 1, 2 must exist on this graph, right? Kind of by logic. And then the second thing is, now that you found a derivative or slope, please create a tangent line equation at 1, 2. All right, so here's what you do. To find a derivative, we got to start from the definition of derivative, which is limit as h goes to 0 of f of x plus h minus f of x over h. Remember, this is just talking about the slope, right? The slope of the function if you move it a little bit farther away, which we call h, and then minus the function divided by how far you move in the x direction, which is h. Okay, so then let's apply. So limit as h goes to 0 of f of x plus h. Remember, that just means x plus h goes into whatever you called x. In this case, we call it t, but you know, it's the same idea. So 2 over x plus h, or you can say t plus h, doesn't really matter, over 2 over x over h. All right, so now if I plug in h equals 0, I'm going to get 0 over 0. Remember, last chapter we said that is the indeterminate form, which tells us there is a limit, but we have to do some tricks. All right, so this one is pretty easy. It's just, you got to recall chapter 1. Least common denominator. Top and bottom. Now you distribute over. I'm going to keep the limit sign because I didn't plug in h equals 0 yet. So then we get 2x minus 2 times x plus h all over h x plus h. Okay, so if you're not familiar with the algebra part, please let me know, or you can review your old algebra notes. Okay, 2x minus 2h all over hx times x plus h. That cancels. We have a minus 2h in the numerator. That h will cancel with the denominator. So then this becomes limit as h goes to 0 of minus 2 over x times x plus h. Now we should be able to plug in h equals 0 and not get a 0 over 0 again. So x times x plus 0. So this is going to be minus 2 over x squared. Please don't write 2x. This is x squared. So basically it's telling me that the derivative at this the derivative of this function is negative 2 over x squared. But it's not actually at this point. This is actually the overall derivative for this equation, or for this function, where basically I can plug in x equals anything and then I would get a slope at that point. But in this problem, we want especially only at this point, 1, 2. So what we're going to do now is sorry, this is kind of busy. I'm going to plug in 1, 2. Or in this case, the derivative says it's just negative 2 over x squared. So I only really need x. So at x equals 1, the derivative, when I plug it in, the derivative is negative 2 over 1 squared, which is negative 2. So it's saying that at that point, 1, 2, the slope of the tangent line is negative 2. So it's a downward slope. Now they say, please find a tangent line equation. Well, ask yourself, what do you really need for a tangent line equation? Or what do you really need to create an equation of a line? Okay, so think about it. Equation of a straight line. You need two things. 1, slope. 2, a point. You need a slope and you need a point. Well, do we have a slope? Yes, it's -2. Do we have a point? Yes, it's 1, 2. So we can create an equation for this line. So here's what you're going to do. You're going to start with point slope form. This is the easiest thing to do. Point slope form. And then from this point slope form, you need slope and point. So really quick, like Algebra 1 review, right? Okay, the point is 1, 2. So y minus 2 equals -2 times x minus 1. And then technically you can leave it here, which I strongly suggest that you do, but you can go ahead and continue to get it into y equals mx plus b if you want. Either way, this is the answer. So what you would do is now, if you want, you can graph this 2 over t. And then you can try to figure out where 1, 2 is, which is on that graph. And then if you were to also graph this tangent line, you will see that the line goes through 1, 2, and is tangent to the graph 2 over t. All right, let's try another one. Find the equation of the tangent line to the function square root x minus 2 at 4, 0. All right, so same thing. If we want an equation of tangent line, we need two things, right? If we want an equation, we need two things. Slope, point. Do we have a point? Yep, at 4, 0. Do we have the slope at that point? Not yet, but we can. We can find the slope at that point by using derivative. So limit as h goes to 0 of f of x plus h minus f of x over h. Limit as h goes to 0 of square root of x plus h minus 2, because this is the function, I'm just substituting x plus h for every word that says x, minus, make sure you put parentheses around it, square root x minus 2 all over h. All right, I'm going to simplify as much as I can in the numerator, so then I don't have to do a lot of things after that. Oh, what is this? Minus 2 minus minus 2. Okay, so the 2 is gone. And we have this. All right, so if you were to plug in 0, again, we're going to get an indeterminate form. So this is where we got to do some tricks. This is where we multiply by the conjugate. So, every time you see a square root, you probably know that you have to multiply by conjugate. All right, keep the limit sign, and then we're going to do this really quickly. So a squared minus b squared. A squared minus b squared all over denominator. Oh, I'm sorry. There was no square on this. Okay, the x is going to cancel. You can see the h is left over, but the h is going to cancel. So then we have left over with limit as h goes to 0. Please don't forget the limit until we substitute. 1 over square root x plus h minus plus square root x. Now plug in 0 for h. We get 1 over square root x plus square root x. That means there are 2 square root x's. So 2 square root x, like that. So this is the derivative at any point to this function. But in this particular question, we just want the slope at 4, 0. So we're just going to find the slope at 4, 0, or just 4, because the equation for the derivative does not depend on y. Okay, so 4, 0, or x equals 4. The derivative is 1 over 2 root x. So then that is 1 over 2 root 4. So that's 1/4. The point is 4, 0. So then the line is y minus 0 equals 1/4 times x minus 4. You can pretty much call it done here, or you can simplify it if you want. 1/4 x minus 1.